So let's just get back into our script here. So we're going to need the target. So first thing that we're going to do is we're going to, let's have a float, and we're going to call this distance to target. Oh. All right, so we have distance to target. Okay. Now, when we want to public, let's do void update. So this will just, every time we have a frame that's drawn, we will call this, it'll run this method for us all through Unity. So distance to target. So we know that target's position. So we're going to do vector3. It's listening, target position is going to equal to transform, not this transform, but this transform, target position. All right, so then we have vector3. We're going to call it marker position, and let's just keep this lowercase. And this will be equal to our transform position. Now, let's calculate the distance between us. So one way you can do that within C# is just do vector3 dot distance. And this will return the distance between our position and the target position. Now, what is it actually doing? So C#, or let's see, Unity has made this little, this struct here for us to use as a vector3. So this will hold 3 values. So our X, our Y, and our Z. And this is just going to calculate the distance. But if we were to do this just on pen and paper here, how we would end up doing this is by simply calculating using, we can use Pythagorean theorem, and we can actually calculate it without using it at all. So let's go into paint real quick. All right, so let's grab ourselves a brush. So let's say we are here, and this is where we want to go. So we can imagine this as triangle. So we have, this is the length, this is the shortest distance, is just a straight line to the target. Now we can go up, we can go up and down. So what we can do is we can calculate this value, we'll call this distance y, and we'll call this one distance x here. And so how we get this, so if we're not directly on 0, 0, let's say this guy here is on 3, 3, and this guy up here is, let's say they're on 9 and 7. Okay, so we can look at this and we can go, well, we're not on 0, 0, 0, 0 is going to be down here somewhere. We're going to need to get our target distance, which is going to be our target x, which is going to be 9. It's going to be 9 minus 3, which is our x over here. And then we're going to do 7 minus 3, which is this number, and this number here, and we'll plug that in. So we'll be able to calculate our y and our x here. So that'll give us 4 over here. So this will be 4. So dx, y, and this will give us 6. So now what does this actually mean? What can we do? We can now use Pythagorean theorem and calculate the distance between it. So d is going to be equal to these guys here. So let's just move all this stuff over here. So our total distance is going to be equal to this. So if we calculate this out, oops, let's grab our brush again. So d is going to be 16 and 36 there. So that will be 52. And if we plug that into a calculator, that'll give us roughly 7.2-ish. Okay, so this is like our total distance at the end of the day. But just using vector.distance, it'll calculate this out for us. But just to show that it'll be the same thing, let's just do a debug.log. So this will just allow us to type out into console and we can read it as we're going. And we're going to call this one, we're going to call it, let's call this vector3 distance versus our calculated one, which I will program out in just a moment here. So we'll do marker position and we will pass in target position. Now why don't we like this? Oh, that's okay. We want it to be using debug equals the Unity one. There you go. Oh, and then we got to make this one, the Unity one is capital L. There we go. So we actually still need to calculate out our things. So if we go back to our example here, what we need to do is we need to get our x and our y. So we're going to go with floats. So let's make dx, dy, and dz, because this is going to be in 3 dimensions. So what does that mean? So dx equals target position dot x minus marker position. dy equals target position dot y minus marker position dot y, and z equals that. So now we do then we're going to take these values here, and we just got to calculate it. I'm in the middle of something.
I'm going.
I'm literally recording for a project. I'm doing stuff.
Okay, goodbye.
Goodbye. Just interrupt. Mom? All right. So now we can actually use Pythagorean theorem here, and we can just calculate this out. So how would this work is we would do dx equals math f dot square root dx, or we'll actually do distance to target equals math x dot square root dx plus math not dx but dy plus we just add all these up together here. Oh wait, we can just go like that, dx plus dy plus dz, and we can see this calculates to the same, or if I have made a slight error, we will find out. All right, so distance to target, there we go. So let's go back into our Unity here, and let's see here if we can get the same. Oh, we forgot to assign our target. that would do it. Okay, so let's go back into Unity, or into the thing here, make sure this is public. That is an important step. And let's go back to our script, let it reload. Oh, we didn't save it, so save it. It'll recompile. Let's go down here. Let's go to our player. Where is our player here? Let's close the environment tab, make this easier for us. There we go. So player armature transform. So distance to target is NAA. Unsolvable. So we actually did make an error here. So let's go dx square root plus dy plus dz. Pythagorean theorem is distance squared, this is what we're looking for, is equal to our a plus our b plus our c's all squared equals d squared. So what we want to change here is we just want d. Oops. And so what we're going to do is d equals square root of all of this, so a, b, and c, plus, make sure all these are squared, squared, and squared. So that's what I need to actually do here. That's what I messed up on. So what we want to do is we want to square root all of this. So dx. So we're going to go actually mathf dot square dot where is it? Power. Yep, there we go. So pow, that's what it is. So f raised to the power of p. So this is going to be our dx, and it's going to be power of 2 plus, that's what I messed up on. Here we go. So we're going to need to do y, and we're going to need to do z. So now it should all work out just fine and dandy. I knew something looked odd when I wrote that the first time. So it's all good. So let's run this real quick. Now we can see we get the same number, but at a higher degree of accuracy here. There we go. It's just rounded up. Beautiful. So as we move closer, we can actually see here at the bottom, we can see the distance is shrinking. We're getting closer and closer and closer to where now I am underneath the object here. We can scroll down and we can see that our distance is 2, and it's just between me and the ball here. So that is good. So next thing we're going to have to do is make it so that number underneath the ball actually updates to the actual distance. So the way we can do that is we can go to our marker. We're actually going to take this guy here, this canvas, we can put underneath our marker, right? So if I duplicate this and move our ball marker around, make a new one. Where is the little handles? Where are the handles? There we go. No, I want on this guy. Okay, well if I move this guy around, if I go over to our marker here, oops. Why doesn't it zoom in properly? It seems to have bugged out. It is all attached proper? Good. Okay, cool. So that's good then. All right, so we're gonna go to our distance to target marker. So now that we've calculated this out, we can see how it's done. So what we're gonna wanna do is we're going to need a public attach mesh pro, which is going to be our, this is going to be our marker text box. Text box. Okay, so every update now, we're going to, instead of printing it out to our debug log here, so let's actually comment code this out so it doesn't run this. So we're going to do text box dot text is going to be equal to mathf round to the nearest int distance to target, which is our current thing. So we're going to round off our target. Oh, it doesn't like that because this is a double. So we're going to make this a float. So that'll have a lower level of size. So if we went back to our Unity real quick, remember before how it was much longer than our float? This is going to give us a more accurate reading. So we're going to take this and we're going to add into a quotation here, and we're going to give it a meters for a unit afterwards. So we will see now that the text box will update once we go to our ball marker and we take our marker.tmp, drag it under. Why aren't you liking that? Oh, I'm using the wrong. Text Mesh Pro. Text Mesh Pro. Oh, that's why. Not TMP. It's TMP Pro. What is it? Okay, so TMP Pro dot text mesh UGUI. That is the correct data type for the component here. So we're going to go here and we're going to grab that and drop you under there. There we go. Beautiful. So now if we walk up to our ball, it'll actually show us the correct distance here. So you see, it's updating as we go. So it says 3 now, 2, 3, but we still have the issue where it is not facing us, and I want to have it at the top where it tells me the actual distance. So let's do that. Now what we're going to want to do is make it so we take our ball. So we're going to do our transform dot rotation, transform dot look at, transform dot rotation. Let's keep that one down there. And then let's make a UI element. Here we go. Let's make a well, actually, I think this is a good stopping point for this kind of clip of it. So basically, all we had gone over is how to make a little marker, how it make it appear. We can make it follow, look at the player, so we can now see it better. And we can walk around and we can kind of move towards it and it tracks us. I think on the next video here, we're going to actually start and set up a compass at the top to let us know where it is, and it'll have the information, its set distance and whatnot underneath it as well. So then if I'm looking this way, I know that maybe the marker will have it appear here and I will have to look this way, and you can kind of see it level out as like look towards it, and it'll center out into the center of the compass. But for now, I believe this is a good stopping point. So we looked at examples, how they work in games and other ones. And yeah, so let's just stop there.